Hey pre-cal kids, welcome back to a new week. This week we're going to start off the week by talking about the law of sines at a more in-depth look. So law of sines, and we're going to look at a very special case called the ambiguous case. So to be ambiguous is going to mean to be unclear a little bit, and that's what happens when we do law of sines. And I want to draw you an example of why. So if we talk about the unit circle, I'm going to focus on the first two quadrants. If I rotate 30 degrees, sine of my 30 degrees equals a half. I also, instead of going 30 degrees, could go 150 degrees. So this red angle that I've drawn is 150 degrees, and sine of 150 degrees also equals a positive 1/2. So when we're looking at the first two quadrants, and the reason we're only looking at the first two quadrants is because this green line that I'm making is 180 degrees, which is the biggest degree you could have in a triangle if you had a triangle. So we're going to focus on the first two quadrants, but sine of 30 degrees and sine of 150 degrees both equate to a half. So when we're doing law of sines using sine, the trig function, and we're staying in the first two quadrants, there's two different angles that we have that could result in the same side length. So this is where the ambiguous case comes from. We don't necessarily always know which one of those two angles caused that side length, the 1/2 in this case, to happen. So the first thing we're going to do is we're going to go to page 62 through 64 in your current pre-cal book, and we're going to look at the different air quotes cases. They're not really numbered like this in real mathematics, but we've numbered them in your book so that we can refer to them and talk about the same cases together. So go ahead and flip to page 62, and we're going to start going through these. Okay, so again, we're going to start on page 62 at the bottom, and the top of page 62 walks you through what I just explained to you about the ambiguous case, and then it says right above the line where this picture starts, so like right up here on your paper, it says we're going to fill in these blanks with a couple of things. The angle line is going to be acute, obtuse, or right. And then it says the lines about side A, side B, and H, you're going to use less than, greater than, or equal to. So let's compare these. So I'm going to label a little bit better so it's clear for you, but this is angle A, which means this over here is side A. They called this side B, and here's my height. So let's read the statement. If angle A is blank, so this angle right here, is it acute, obtuse, or right? Correct. It's an acute angle. So if angle A is acute and A blank H, so what we're comparing right here is side A over here to the height. Well, based on this picture, side A is definitely less than the height, then blank triangles exist. So I'm going to draw in here to the best of my ability. What they're saying is this little A right here, can I swing it out this way or in this way, and how many triangles can I make? The problem is, you see this red dotted line they had to make you use red. This red dotted line in here, when I swing side A back and forth, side A is never long enough to touch down here. Since it's never long to touch, I never can complete the triangle, so 0 triangles exist. Let's try cases 2, 3, and 4. Okay, so let's start up top. So in case 2, this angle A right here is acute, and A blank H. Well, look right here. A and H are labeled on the same side. So what do you think you can tell me about side A and side H? They are the same, so they are equal. If the height and side A are the same length, you can only make one triangle. It's a horrible one. Let me fix that. You can only make one triangle. It's this one right triangle where A equals H, forming this 90-degree angle right there. Okay, let's go to case 3. So we're always going to start with angle A. And I should tell you this just to make sure you understand. The ambiguous case comes from the side-side angle. Side-side angle equals ambiguous. We're never going to have an angle side-side. We're not going to talk about it. We don't put the letters in that order. But we have a side-side angle. And so when they do this, they always call the side-side angle, they always call it A, B, and then because this is across from that, they always call this one big A. These letters are not important because you can call them anything you want. We could have called it B, A, and big B, but what's important is that you understand how to construct the figure, that it's always going to be the side angle. Okay, let me erase some of this coloring. Okay, so let's go back to doing this problem. So this angle A right here is acute. B blank A. So now we're going to compare. We're going to compare side A over here with side B. So if you compare the length of side A to B, A is bigger than B. That means from this height right here, I can only swing the A side out this way. If I tried to swing the A in this way, it would be too long. It'd be longer than this line. So I only can make one triangle. So if angle A is acute and the A is bigger than B, then we only have one triangle. Case 4. So let's look at angle A first. This angle down here is acute. And then we're going to compare side A to my height. Well, it seems that A is a little bit longer than the height because the height is the straight line, the shortest distance between 2 points, and A is a little bit bigger. So A is bigger than H, but this side A that we have here, or here, there's 2 A's in this picture, they're the same thing, it is less than B. So when H is smaller than A and A is smaller than B, then I have 2 options. I can swing side A out and make this green triangle that I was talking about, or I can swing side A in past the height and make this triangle that I'm talking about. This is the ambiguous case. Because this angle in here and this angle in here are like my 30 degrees. That would be the 30. And because this one's obtuse, this would be the 150 degrees, where the sine value is exactly the same. So again, if angle A is acute and side A, this side over here, is between H and B, then we're going to have 2 triangles. And this is the ambiguous case. Okay, one more page. Go to page 64. Let's talk about 2 more cases we could have. Okay, these last 2 cases are a little bit different because let's look at angle A. Angle A down here is definitely now obtuse. So this is why we look at the angle first. When we look at the angle first, we know whether we're going to be on pages 62 and 63, cases 1 through 4, or if it's obtuse, we go straight to page 64. So if angle A is obtuse, and then this side A compared to side B, what can you tell me about this little side A compared to this big side B? A is, that's right, A is less than B. Or if A was equal to B, if they were the exact same length, the second that I tried to rotate out this way, I would be a little bit short. So that's why the or is there. Or A equals B, then we have 0 triangles. We can't make any because we're never going to be long enough to touch the line down here, ever. Okay, case 6. If angle A is, what is this angle right here? Angle A is obtuse. And then we're going to compare side A to side B. What can you tell me about side A to side B? That's right, A is bigger than B. Then we only have 1 triangle. It means we only can swing the A this way out. If we tried to swing A this way, we would be changing angle A at the bottom, and we're not allowed to do that. So we only can swing it out to make this big green triangle right here. Okay, so let's walk through a couple of these problems so that you can see how this works. So we're going to skip to page 69, and we're going to do the left-hand column where you're just determining how many triangles can be created. Okay, on page 69 on the left-hand column, we're going to just state how many triangles can possibly be made. So first of all, let's just talk about this again. The ambiguous case happens when I have a side-side angle. So side-side angle. So side-side angle. Doesn't matter up here what they labeled them as, but that's how we're going to make the triangle happen. So let's do... So the angle they give me is C. So this is C, and this is 63 degrees. If this is big C, the angle, then across from it is little c, the side, which is 12. And then we have to make our other side here B equals 9. So the questions you should ask yourself are, 1, angle is blank. The angle they give me is acute. So we're looking at cases. This symbol that I'm drawing means therefore. Therefore, cases 1 through 4. The next thing we need to find once we do that is the height, because in all of cases 1 through 4, it compares my sides to the height. So let's talk about how to find the height for a second. I'm going to draw the height in right here. So if I want to find the height right there, I have this right triangle that I'm outlining in blue. So what I can do is, it's always side, sine this angle. Side times sine of the angle. And this side and this angle right here should not be the same letter. So in our case, it's going to be 9 sine 63 degrees. So I'm going to grab my calculator real quick, and I'm going to type that in so that we can find out what the answer is. So I made sure my calculator was in degrees, or you can put the degree symbol, but you're going to do 9 sine 63. And it's going to tell you this length, this height. This is going to make my height, this thing right here, my height, is going to be 8.01906. I'm going to write all the decimals down, so I'm about to compare sides. So now I need to compare this, grab a different color really quick. Now I need to compare this side over here to my height. So this side that I have over here, in our notes it's called A, and this picture it's called C. It doesn't matter. This, we call it the swing side. The swing side, the side that could swing out or maybe in, is bigger than my height. So in your notes it's going to say A is bigger than my height. So that means I could maybe swing it in or out because I'm going to be longer than the height, so I could go in or out. But now we need to compare this 12 to the 9, the side B. So right now what I'm looking at is on page 63, because this swing side over here is bigger than my height, I'm looking at either cases 3 or 4. It can't be case 1 because this swing side over here is not smaller than my height. It doesn't equal my height, so I'm not case 2. So I'm either case 3 or case 4. A in this case, again, which we're calling C, is bigger than my B, which means I could have stopped at case 3, because since 12 is bigger than my 9, my only option is to swing this out, not in, just out like this. So that means I only can make one triangle, which is case 3 in your notes. So let's try another one. Let's try number 2 on page 69. So it tells me that the measure of angle B equals 33 degrees. A equals 27 and side B equals 22. So again, always side, side, angle. So this angle in here, which we're going to call B, is going to be 33 degrees. So question 1. Angle is blank. This angle is acute. So that means we're down to cases 1 through 4. And now we have side, if this is side B, then across from it is, sorry, if that's angle B, across from angle B is side B. So this is 22. And then that means this is A over here, it's 27. This is A, this is B. So let's compare A and B. In this case, B, my swing side, is smaller than A. That means I possibly could swing it out or swing it in, but I don't know if I can even touch the bottom down here yet until I find the height. So let's find that height. Height is always going to be side, sine, angle. Side, sine, your angle. So in my case, it's going to be 27 times sine of 33 degrees. You can either make sure you put that degree symbol in or change your calculator degrees. Either way will work. So 27 times, press that trig button, grab sine 33, and then I like to put the degree symbol. That height right here, this height right here that I have to be at least that to make any triangles, it's going to be 14.7053. That means B, my swing side, is greater than the height. So I can make a triangle, and because B is less than A, I can swing it out and make this triangle, or I could swing it in and make this triangle. This is an ambiguous case. You can make 2 triangles. Let's try another one. Let's try number, I'm going to skip number 3. Let's try number 4. So now we're on number 4, and it says that B, my angle B, is 95 degrees. It says that little b, my side, is 24, and that little a is 5. Again, remember, always side, side, angle. But in this case, I need to draw a little bit more accurately, and here's why. Let me cross that one off with red. This angle is obtuse, so it's going to be side, side, and then this is going to be my obtuse angle down here. So my angle B down here is 95. And so the first question this time is angle is blank. It's obtuse, which means we're looking at case 5 or case 6, but not 1 through 4 because my angle is obtuse. And so if this is angle B, then this is side B over here, 24. That means this over here is A, which is 5. So this means that I can make 0 or 1 triangle. The answer is 1 because B is bigger than A. This is my shorter distance, so I can swing B out this way and make my triangle. So because 24 is bigger than 5, I can make 1 triangle. Okay, so now I'm going to go back to page 67, and we're going to walk through the math to not only figure out how many triangles there are, but then find the missing pieces.